Hey guys, hope you're doing well. In this video, I'm going to talk about what a network SRE or network software engineer really do in FANG. In the past few years, I think you have already heard all these buzzwords such as automation, Python, and software-defined networking, or even questions such as what is the future for network engineer, or is network engineering dying? So, do you really know the reason behind? If you don't, then you are in the right place because in this video, I'm going to show you what a real network developer really do in FAN to answer those questions. Before we going any further, let's take a look at some of the history. About 10 to 15 years ago, when the internet is booming, Cisco in particular really dominated the market. That's why you see lots of people trying to crack their certifications such as CCNA, CCNP, or CCIE. The old job that I have as a network engineer back then is really about deploying vendor solution for solving different architectural issues, expansion needs for the managed customer from different industry. And oftentimes you do see a dedicated network team in every big enterprise taking care of the day-to-day operation. When issue happen on any of these vendor solution, either hardware issue or software issue, you engage the full circles of raising trouble cases with the vendor all the way to the contracted IMA supplier for fixing. Since these are all about vendor login solution, there is not much room you can leverage, and basically you just do what the vendor told you to. And therefore, network infra often regarded as one of the biggest asset in big enterprise because they are not cheap to run and maintain comparing to servers. From manageability standpoint, since different vendors have different way of doing the same thing, it creates challenges for managing them at scale, especially from the configuration standpoint. Most of the network issue that I have seen in the past is due to snowflake configuration made by human, and they are costly to fix. Time fly. Until recent years, with the initiative of open networking, one of the big players out there, such as Facebook, has been one of the major initiator to embrace the idea and drive the industry toward openness. So, what do I mean by that? The industry is now driving toward the same footpath as commodity server. That means separating the hardware from software. So, in terms of hardware, one of the well-known community embracing the idea is called the Open Compute Project. They are gathering major engineer, developers, suppliers together to help grow, drive, and support the open network hardware ecosystem around data center and beyond. Every year, they have events for showcasing their development and innovation. As an example, check out some of the network engineering blog out there, such as Facebook engineering blog. I have included links in the description section if you're interested. They have engineered and manufactured custom hardware such as optical transceivers, switches, and even chipset for meeting their needs. Also, they have submitted their solution to the community for others to adopt. Facebook is only one of the many in the industry doing it. I know for sure that other big players such as Microsoft, Amazon, Google, and LinkedIn are doing the same. In terms of software, like what I have mentioned on some of my previous video, I have emphasis on the importance of learning Linux. This is because Linux is a base system that many network OS is developed upon. Some of the hottest open source nodes I know and can recommend are the Microsoft Sonic and NVIDIA Cumulus. Although they share many similarity, There are some subtle differences on the implementation. I'm not going deep into this system design and detail as they are out of scope. If you're interested, I will do a separate deep dive on them in a separate videos. So now let's take a look at what is the pros and cons of this approach. Advantages, they are very cost effective comparing to vendor solution. That means no more vendor license fee. So it is not hard to see why many cloud ISP are ramping up this solution massively, where you can find tens of thousands of these devices in their data center. Openness on the software means more innovation and room for developing custom solution for solving some specific issue for different environments. In terms of the disadvantages, support is the issue, since development, deployment, and maintainability require knowledge and skill set beyond a typical network engineer. That's why network engineers need to upskill and grow. This also partially answers some of the initial questions. Network management. Up to this point, I believe you probably get an idea on what a typical FANG-like company network infra looks like. We are looking at thousands of this custom open hardware and software. This ain't no Cisco or Juniper solution you typically use. I guess I don't even need to go deep into this system architectural design, such as distributed, semi-distributed, or even centralized SDN approach. So how do we scale and manage them? Obviously, this kind of a network build is not for human. So reliable tools are very essential. We need tools for network configuration. We need tools for network monitoring. We need tools for troubleshooting. We need tools for network auto remediation. Now you wonder, who create and own this tool? The answer is network engineer. Yes, it's network engineer, but it's not a typical network engineer. It's next-gen network engineer. With all that said, now we know why there is a need for network automation, Python, or even SDN approach. Also, network engineering is definitely not dying, but instead taking a transformation. Regardless what network infrastructures you are working on or looking after, in the long run, I suggest you better start upskilling now rather than later. That's it for this video. I hope you enjoy it, and I see you on the next one.